Okay, so today we're going to take our first actual notes on the water cycle. This is how this needs to be labeled in your notebook. On a page of your notebook, write water cycle notes at the top. And we're going to draw a little diagram here. We're going to draw a little picture. Now, it's going to be a very easy picture, and I'm going to walk you through it. Normally, I'd give you a handout, and that would already have the picture on there. But in these times, I can't give you a paper copy, so we're going to draw. We're going to need this full top space on our page about this size. And I'm going to draw maybe a little bit extra big so that you guys can read it on the video. So the first thing, take a line here, and I'm going to draw myself a mountain. Just draw yourself a triangle. And that for us is going to represent a mountain. There's my ground. Over here, I want to represent the ocean. So I've got a mountain, got some regular old land, and over here I've got my ocean. Now, let's talk about what we know happens in the water cycle based on what we learned fall semester. We know that water in the ocean will evaporate, go up into the sky, and form clouds. And then clouds drop precipitation back onto the ground. So that's the first part of our water cycle. That much we learned fall semester. So I'm gonna show that on my pattern here. I'm going to show myself an arrow, and I want to draw myself a cloud up here. And I'm going to label that number 1. The first part of my water cycle, I'm going to come down here. Number 1. Is evaporation. And this is where water goes into the air. Now, if we think about evaporation doesn't just happen from the ocean. It can also happen from a lake or any other collection of water on the ground. Well, I don't have a lake drawn on here, but I am going to draw one. Let me do something like this. I'll draw myself a little lake. So there's my lake. And I know evaporation also happens from a lake. So these are 2 ways in which water can get into the sky and form a cloud. But when we did our little water cycle game conclusion thing the other day, there was another way, another couple of places where water can get up into the sky and form a cloud. So if we think about another collection of water on the ground, I'm going to come over here to my mountain. I want to draw that. Big snow-capped mountain. We know that big, tall mountains have big collections of snow and ice on them. Those are called glaciers. And water from glaciers can also evaporate. I'm going to draw something like this. This is also number 1. These are all showing me how, or places where water can evaporate from and then go up into the sky and form a cloud. And that's part of the water cycle. Now, there's actually one other place that water can evaporate from. There's one other place that water is found in the water cycle, and it evaporates and goes up into the sky, and that's you and me. That's animals. Animals also evaporate their sweat, and it goes up into the sky. So I want to draw an animal on here somewhere. And I am not a great artist. This is about the extent of my artistic capability here. If you like to make nicer, prettier animals, I encourage you to do so. So I want to draw myself maybe like, I don't know, a horse, maybe a dog, I don't know, whatever you want to call that. But that's obviously an animal. If you wanted to draw this as a stick person, that would also work. These are all places where evaporation can happen from. Water can evaporate from ice or a glacier. Water can evaporate from a lake or a pond. Rivers are kind of the same thing. They're fresh water on the surface. Water can certainly evaporate from the oceans, and water can evaporate from animals. Okay, so that's the first part of our water cycle here. But there's a lot more than animals down here that are spitting out water into the air. Plants also do the same thing. But plants don't sweat. So we're not going to call that evaporation. For my plant, I'm going to draw myself a tree. And I know a tree takes water out of the ground and then spits it into the air through its leaves. And we talked about that process fall semester as well, because that's something that plants can do to help keep temperatures down. Well, that process has a name. That's called transpiration. That's where plants take water out of the ground and they spit it up into the air out their leaves. Well, that water that is then in the air can go to a cloud and help make rain. That's part of the water cycle. I'm going to label that number 2. That's transpiration, which is a little bit different than evaporation. It's a different process. So these are all things that we talked about last semester. Water evaporates, comes up in the sky, uh, forms a cloud. But what's happening up here in the cloud? Why do we get a cloud? The water in the air goes up high enough in the sky where it's cold enough that water starts to stick together in big enough quantities that we can see it. That cloud formation, that's part of the water cycle. That has a name, and we're going to label that number 3. That is condensation. That's water in the air cools, usually because it's high up here where it's cold enough. So it starts to stick together and forms clouds. If the water doesn't get cold enough to stick together and form a cloud, it will never rain. Well, you know that rain or precipitation is part of the water cycle. That's how water gets moving through these different locations. If it never rained, we would never have rivers, lakes, streams. We wouldn't have water to be able to drink. We wouldn't have water to spit out or pee out. So it's all part of this water cycle process. Okay, so this is all stuff that we talked about fall semester. Still, evaporation, transpiration, condensation. But there's a name for the water that comes out of the sky. That we know is precipitation. Precipitation is any water that falls from the sky. And that can be rain, sleet, snow, hail. It can be a lot of different things. Now, I want to show that on here. This is a cloud that's kind of collecting water and condensing. It's building, it's collecting water. I'm going to come over here. I'm going to draw a different cloud. For me, I'm going to color that cloud dark. It's a cloud that is full of water now. Now it's going to start to drop it. If you want to draw little raindrops, some of you that are much better artists than me, please feel free to embellish this. But there, I've got a cloud that is dropping water. That is precipitation. Now, here's where this semester is a little bit different, and we're going to start talking about things that we haven't looked at last semester. And that is, well, once this water falls from the sky, what does it do? Well, we know that water from rain will make its way into a lake. A tree will drink it from the soil. An animal will drink it from a river. And then it gets put back into the water cycle a different way. But there is a name for the process by which water moves across the surface. Now, we know what this is. We know this is, evaporation. It's going this way. We know that coming down is precipitation. But moving across the surface has a name. And you know that when it rains, water will run downhill. You've seen it after a rainstorm. You see the not just puddles forming, because puddles are sitting there, but water running down the streets when it rains real hard. It's going downhill. That process has a name. That's number 5. That process is called runoff. That's when water from precipitation moves across the ground. That's what we typically think about when we're talking about rivers and streams. A river is just a big collection of runoff. It's water that's moving across the surface. It's flowing somewhere. That's runoff. Runoff is moving. A big lake is not runoff. It might be formed from runoff, but it's not the actual process of runoff because it is not moving across the surface. So you'll notice how I drew this. Oh, we got an arrow. It's coming down, and then it's moving across the surface. That is what runoff is. Now, not every drop of rain that hits the ground becomes runoff. Some water actually will soak into the ground. And you've seen this before when it rains and the ground is wet. The water's just sitting on the ground and it's not moving anywhere. And you come back a few days later and the ground's not wet anymore. Well, what's happened is the water has either evaporated or water sinks into the ground. It does it kind of slowly. It doesn't happen instantly, but the water will seep into the ground. So this runoff water will also do that. Water seeps into the ground. That's my 6th process here. This is called infiltration. Infiltration is water that moves into the ground. Infiltration is water that moves into the ground. And anytime it rains and you get water that's sliding downhill or just sitting on your front yard, some of it is actually going to soak into the ground. We can get infiltration some other places as well. My picture of the cow peeing on the ground, that's an example of infiltration. The cow peed on the ground and the pee soaked into the ground. That's an example of infiltration. Another way in which modern people, infiltrate water into the ground is if you don't have a sewer system, like most of us here in the city, you have what's called a septic tank. People out in the country, their toilets don't go to a water treatment plant. It just goes to a big tank that's buried out in their yard. And when they flush the toilet, the water goes into that tank, and then the water just slowly goes into the ground. And that's a way for it to get back in this water cycle. People out in the country live too far from a water treatment plant, and you can't lay miles and miles and miles of pipe to get to a water treatment plant that might be 20, 30 miles away. It's just not cost effective. So you build what's called a septic tank, and that's a process by which water can infiltrate back into the ground and stay in this natural water cycle. So water can infiltrate the ground from rain runoff. It can infiltrate the ground from animals. Another place that water can infiltrate is from glaciers or ice. If you've ever lived anywhere where it snows a lot and it stays very cold, the snow will stay on the ground. It won't really melt, but it does get pushed into the ground. Places that have a lot of snow and ice on the surface will have water pushed into the ground. It will infiltrate into the ground from the weight of all of the snow that's on top. Farmers in the Midwest actually like snow more than they like rain, because rain will actually run off. It slides off and it goes somewhere else. Well, if you're a farmer and you want your soil to be wet, you want water in the ground, well, snow will sit there and slowly infiltrate the ground. It will actually make your ground wetter than rain will. So that's an example of infiltration. Now, there's one other concept here, and I'm going to I have to draw something new. I'm going to draw like something like this. Now, what happens when water infiltrates into the ground is it gets down there under the soil and becomes what we call groundwater. You know that if you dig a well, you've seen this in movies and shows, you understand the whole hand crank well thing, you drop a bucket down there, you can collect water. Under the ground, there's always a collection of water, and it's from that water that is infiltrated. You can think of it as like an underground lake, even though it's not necessarily hollow. That has a name that we're going to explore later this week. That's what's called the aquifer. The aquifer is that collection of underground water. So water gets underground and it hangs out. Water on the surface hangs out in a lake, or it hangs out in the ocean. Now, there's something that a couple of these places have in common. A glacier. The water in the ice is just sitting there. Water in the ocean sits there a long time. Water in a lake sits there a long time. Groundwater in the aquifer sits there a long time. When we did our water cycle game, we noted on our little map that we drew that these are places where water stays a long time. Water doesn't stay in a cloud very long. Almost as soon as the cloud fills up, it drops it for a couple of days maybe. You know that water doesn't stay in animals very long. As soon as you drink it, you're going to pass it back out either this way or this way within a few hours. Plants, same way. They take water from the soil and they spit it out so quickly that you got to keep water in your plants or else they'll go dry and die. But glaciers, these aquifers underground, lakes, and oceans are places where water doesn't move through quickly. It just hangs out. It sits there. In the ocean and in aquifers, we're talking thousands of years. Water molecule can get there and it can be trapped and just hang out for a long time. Well, there's a name for that situation. I'm going to label this number 7. A glacier is an example of this. An aquifer is an example of this. A lake, and certainly the ocean. Number 7 is a concept that we call storage. So storage refers to water that stays in one place in the water cycle for a long time. That's glaciers, that's aquifers, oceans, and lakes. It is not people. It is not runoff. It's not clouds, because those are all examples of places where water moves through it very quickly. Storage is a general term that is used to describe water that sits in place for a long time. Now, when you are finished with these notes and drawing this diagram, I need you to take a picture of it and submit this on Teams for your daily grade for today. And you will be able to use this on the test and the quizzes. And it will be fairly much word for word from this list. And I promise you will see an electronic version of this diagram on your next quiz.